All right, welcome back, Grade 7 learners, to this explainer on the setup and first-run workflow for conditional statements in Python. Have you ever typed code into the interactive Python prompt, smashed that enter key, and absolutely nothing happened? Or maybe the prompt just changed its shape and left you hanging? Well, you're in exactly the right place. Today, we're going to figure out exactly how the Python interpreter actually thinks.
Here's our roadmap for today. First, our lesson setup workflow. Then, we'll dive into why structured execution matters. After that, we look at evidence with compound if statements and test it out with a modeled decision in our interactive workflow. Finally, we'll tackle that huge misconception about the continuation prompt and wrap up with a quick retrieval check and lesson takeaway. Let's jump right in.
Section 1, our lesson setup workflow. Okay, so first things first, we really need to establish a pristine, totally isolated workspace. Why? Well, when we write and test Python logic, we definitely don't want to accidentally mess with other projects on our computer. So we use the venv module to create what's called a virtual environment. You can literally think of it like a protective bubble, a self-contained directory tree made just for our lesson's code. It gets its very own copy of the Python interpreter and all the supporting files, keeping everything perfectly safe and isolated.
Let's actually look at the steps to build this foundation. Step 1, you just run this command in your terminal. Python-m ven tutorial env. Easy, right? Step 2, you got to activate it. If you're on Mac or Linux, you'll type source tutorial env /bin/activate. Windows users, you'll use tutorial env /scripts /activate. You'll actually know it worked because your shell prompt is going to change to show the environment's name. And finally, step 3, we start up the interpreter by just typing our Python command, something like Python 3.14. Boom, we are officially in interactive mode.
Moving on to Section 2. Claim, structured execution matters.
So now that our interpreter is up and running, we arrive at the real core of our explainer today. Here's the thing. Writing code is honestly only half the battle. You have to precisely navigate the interpreter's rules to actually get it to run. See, the interactive interpreter isn't just some casual chat window where you type whatever and it figures it out. No way. It operates by a very strict rulebook. If you don't structure your input exactly how it expects, your logic just isn't going to execute.
And this strict rulebook, it applies to literally everything, even how it reads your plain text. By default, Python expects your source code to be encoded in UTF-8. That's a standard encoding where characters from most of the world's languages can be used. It's just a great reminder that this environment operates on strict, predefined behaviors from the exact second you hit start.
All right, Section 3, evidence, compound if statements.
To really prove this point about strict rules, let's look at the official Python documentation on how if statements are built. An if statement actually isn't just a simple single-line command. In Python, an if statement is what's known as a compound statement. Basically, that means it contains groups of other statements, and it consists of two absolutely vital parts, a header and an indented block of code that we call a suite.
The official rulebook is super clear here. After the if keyword, your condition, and the colon, you are absolutely required to provide that indented block of code. Honestly, think of that colon at the end of the header as a flashing red light telling the interpreter, hey, more code is coming next. If you forget to indent the next line, Python is going to throw an error right back at you, simply because the strict rules of a compound statement were broken.
Let's see this in action. Section 4, Model Decision Interactive Workflow.
Okay, let's put this evidence to the test and model an actual workflow right out of the Python docs. Imagine we're sitting in our activated virtual environment. At the primary prompt, the one with those 3 greater than signs, we assign the value true to our variable to set up our condition. We type the world is flat equals true and hit enter. The interpreter processes this simple statement right away and gives us a fresh primary prompt.
But now, let's try our compound statement. We carefully type our header if the world is flat. When we hit enter this time, something shifts. We do not get that primary prompt back. Instead, we precisely indent our suite, in this case a print command, on the very next line, right next to a totally different symbol, 3 little dots.
Which brings us perfectly to Section 5, Misconception, the continuation prompt.
This right here is a massive boundary check for a misconception so many students run into. You might think hitting enter runs the code immediately, right? But actually, the interpreter switches to a secondary prompt. Just compare them. The primary prompt, the 3 greater than signs, is for starting a new statement, but the secondary prompt, the 3 dots, is for continuation lines. When the interpreter sees that colon at the end of your if header, it knows you're building a multi-line construct. Those 3 dots are basically it saying, hey, I'm still waiting for the rest of your statement.
So, here is the big misconception. Students type their print statement, hit enter once, see those 3 dots, and completely panic. They wonder why the code isn't running and think it's broken. But here's the golden rule you have to remember. You must hit enter on a blank line to close out the suite and force the interpreter to execute. That blank line is literally your way of telling the strict interpreter, okay, I'm totally done with my indented suite, now please run the code.
Let's wrap this up. Section 6. Retrieval and lesson takeaway.
Let's lock in this specific workflow knowledge before you go off and write your own logic. Take a quick second to test your memory. Imagine you're typing your if statement into the terminal. What exact symbol indicates to you that the interpreter is waiting for your indented suite?
Did you guess it? If you remembered the 3 dots of the secondary prompt, you absolutely nailed it. Awesome job! Those 3 dots mean you're stuck inside a multi-line construct, and you gotta provide that blank line to execute it.
Okay, one last question for you. Once you've successfully tested your logic and you've watched your print statement execute perfectly, what is the actual procedure for exiting our isolated setup? We open the environment and we open the interpreter, so how do we shut them down?
Here's the trick. You first have to type quit with parentheses to leave the interactive mode. Actually, you can also use Control-D on Mac or Control-Z on Windows. Once you do that, you're dropped back into your shell, but you're still inside your isolated workspace. To gracefully exit the tutorial env directory itself, you just run the deactivate command.
So let's do a quick recap. Our big takeaway today is that flawlessly testing conditional statements means you have to master both the isolated environment setup and the interactive prompt rules. You isolate with your then, you recognize that an if statement is a compound statement requiring a header and an indented suite, you watch out for those 3 dots, and you always execute your multi-line statements with a blank line.
As we close out this explainer, I want you to think about this. Now that you control the environment, and you completely understand the rules for compound statements, if you can master exactly how this strict interpreter thinks today, what kind of complex, multi-level games or decision-making bots are you going to build tomorrow? Keep experimenting, keep a close eye on your prompts, and happy coding!